Every AI model you've used, ChatGPT, Midjourney, whatever, runs on something called a neural network. But here's the thing nobody tells you. There's no thinking in there at all. It's just detectives guessing, getting yelled at when they're wrong tens millions times in a row.
Not detectives, numbers adjusting other numbers. The AI that matters, every day.
So let's look at how AI actually works. Let's start with neural networks. As I said, the exact definition is a mathematical structure of connected layers of nodes called neurons, each with a weight that transforms input data into output through successive layers of computation. So it consists of tiny computational units that are called layers of nodes or neurons, organized into distinct layers. So these layers are these three different layers. We have the first layer that, as it put in the definition, it's the input layer, the raw data that these models are trained. It's the exact same thing, this input layer. Then we have the hidden layers that are the pattern extraction that these AI models do. From all this raw data, they extract the patterns to recognize patterns and be able to predict the next word. Then we have the output layer, that is the prediction phase, that from those patterns, then they are able to predict. So first we have all the raw data they are trained on, then they extract the pattern recognition, and then they are able to predict. So in this first input layer, from all the raw data, they receive raw data, like for example images, text, tokens, or audio frequencies, all this raw data. Then in the hidden layers, these are intermediary layers where networks extract features and complex patterns. So with extracting these complex patterns, then they are now able to recognize those patterns and predict. And these constraints are called deep learning. And then in the prediction phase, they convert the processed signal into a final answer, into a final output, into your answers that you get, such as a category label cat versus dog or a probability score. So to understand it better, here's how neural networks learn. We are going to use this skateboarding example. First, they trial. They have all the raw data, so they try skateboarding, for example. Then they hit an error, so they fall. But then they adjust something, and then they try it again. And it's this self-improving loop that keeps improving. So for example, in here, we have like raw data, for example, of dogs and cats. In here, they try to recognize a pattern from dogs and cats to be able to distinguish between those two, from an image from a dog and from an image from a cat. Then they now have failed because they put an image of a dog as an image of a cat, and then a human tells that is not correct. Then they see that it's an error, so they adjust it and try it again. And here's how the neural network learns, keeps improving. Then we are going to put this mystery panel analogy to help you understand better what are neural networks. So first, let's get you into context. You are trying to guess a movie title based on individual clues, and you have a team of 3 specialized detectives helping you out. So we have these 3 things, the exact same things as in here, but with this mystery panel analogy. We have first the clues, the input. These clues are, you have cape, bat, and dark. These are just raw clues. Then the 3 specialized detectives that are action, animal, and heroes. And then we have the final movie guess. From these clues and input, from these clues of input, and the 3 specialized detectives that are the neurons, as in here. So for example, detective 1 is specialized in genre and sees cape and things. It's either superheroes genre or horror genre. Then detective 2, that it's a settings specialist that sees Godman and things. It's either DC Comics or comic books. Then we have detective 3, that it's nature specialist. She's a bat and thinks documentary or animal film. So we have these three detective, and these three detective has weights. So detective 2 rarely misses setting clues. So you give their opinion high weight. So high weight is like giving the opinion of detective 2 high value to that opinion. Then, for example, you tell detective 3, we aren't watching National Geographic right now, so you are wrong. So you lower their weight. So this is not as important, and this is the most important one. So you have to look at this more than looking at these two, and this one is in the middle, the detective one. So from these three specialized detectives and the clues that we have, Cape, Bad, Dark, these raw clues, we get the final movie answer, the same that we got in here, the exact prediction as we had in here. This is the exact layers, and in this mystery panel analogy, it's the final movie guess. So what movie is it? So the final guess, the output. So the detective now, they share their scores, you combine them, and the system declares a fact. 99% chance the movie is Batman. That is their prediction. And this is how the layers of neural network work. So just with this analogy, you are able to understand them. Just bear in mind these clues. For example, Kate, Batman, Dark. 3 specialized detectives that look into 3 different things: gender, settings, and nature. And then the final movie guess, the exact prediction they share. So they say it's Batman, and it's correct. So how do detectives keep getting better? We saw it like in this neural network learn, trial, error, and adjustment. But how do they keep getting better? Because when you first hire this team, they are terrible at their jobs. For example, this is saying that it's a documentary on animal film. So how does it actually work? So it works like this. First, we have different rounds. The round 1, you give the clues, as before with Batman. Laser, for example, we can make another analogy of a movie. You give them laser, space, and Vader. The team guesses a documentary about space. Then you tell them, no, that is not correct. That is an error. Wrong, it's Star Wars, for God's sake. It's not a documentary about space. Don't you see Vader in here? Vader is from Star Wars. Then they fix it, and it's called backpropagation.
Still not detectives. Here's what actually happens. The network makes a guess, checks how wrong it was, and that error becomes one number. That number flows backward through the network, and every weight shifts by a fraction, proportional to how much it caused the mistake. That's the whole meeting. No conversation, just calculus 10 million times, one small nudge at a time.
The detectives meet up and adjust their focus. Then Detective 1 realizes when Vader appears, ignore space and guess sci-fi action immediately. So Star Wars, not a documentary about space, no, a movie about science fiction if it appears Dark Vader. So after playing this game and then with this Detective 1 realizing it, it goes back to round 1, and this improving loop that keeps going after playing this game 10 million times with thousands of movings, the detective learns exactly which clues matter and which clues don't, which one gets ignored and which ones don't, and how to work together all these detectives, all these specialized agents detectives. So then, why am I explaining you this? Because of this. Because these neural networks are engines driving modern technological breakthroughs that you see today. So thanks to neural networks, we can see all these new frontier AI models that are so capable and intelligent. Thanks to that, because thanks to understanding this, you know what AI can do and how to build with it, and where it breaks and doesn't work correctly. So to use wisely these AI models from Cloud or ChatGPT, you first need to understand neural networks. And what has happened is that people just have taken action and go to the practical stuff using AI models. But you also need to know the technical and the vocabulary and all the concepts inside AI to help you build better with AI and use it wisely and more productive for you, so you can use it more efficiently. So we have these three things: AI, machine learning, and neural networks. So neural networks, like the deep learning that we talk about, is just at the core center. Then we have the machine learning, and then on top of that we have artificial intelligence. That's what you probably know and what you are using right now. So neural networks is the architecture, is the whole building, is every modern AI model, whatever it generates text, images, to speech to audio, or operates autonomous agents, and you can create your own specialized agents, like with Grokbot or Kik, is built on a neural network architecture like transformers, that we'll just talk about it in a second. So, neural networks architecture. Then machine learning, ML, is the method. The method of this architecture is giving computers this large database, all this raw data, so they can learn these patterns automatically. So you put them all these millions of data, that this is the part of the training phase, that it costs a lot of money. So all this data, so then they can recognize patterns rather than programming every step manually. So you give them the data and they figure it out patterns, so they can predict the next word, because this is how AI works. So machine learning, the method, and then we have artificial intelligence, that this is the goal, the final goal, is getting computers to mimic this human reasoning, decision making, or creative tasks. So being able to do tasks like humans do, or even better. This is the goal of artificial intelligence. But behind artificial intelligence, there is the machine learning, that artificial intelligence has these different steps. This how an AI model is made with machine learning, with giving it raw data, training it so it can recognize patterns and predict, and then putting it out into the public so you can use it every day. So behind AI we have machine learning and neural networks that are built on architectures like transformers. So what are transformers? Transformers is a specific type of neural network architecture, a specific type of neural network. And transformer was invented by Google, by a paper that it's very common. You may have heard the name, Attention is all you need. It was called like that. Attention is all you need. It was introduced by Google researchers in 2017. And it's the core engine behind virtually all modern generative AI. That generative AI means that they generate something new, an output, a new output. So all these models generate new text, new images, new videos. You just tell them what you want and they generate something new. They don't, so if you ask for a text, if you ask for an image of a cat, they don't give you an already made image, no. They generate it on the go when you say it, so it's called generative AI because they generate. It's simple to remember this name. So this transformer, this attention is all you need, it's the core engine of all these models that you see in here of Claude, ChatGPT, Gemini, Grok, DeepSeek, Kimi, etc. So why was the transformer a game changer? So we have how we had it before and after. Before they used recurrent neural networks that read text word by word sequentially, left to right, text by text. But this made two problems: the memory loss and slow training. Memory loss because when it kept reading, it didn't remember the first sentence that it read, so it kept forgetting things. Then it was very slow to do that word by word, left to right. So when Google found out about transformers and invented this, attention is all you need, we have this after transformation. the transformers, that solve both of these problems with recurrent neural networks, the memory loss and slow training. It solves both of them. It processes entire blocks of text all at once, not word by word, no, entire blocks all at once, at the same exact time. And also, it learned connections between all words simultaneously, so it didn't forget the sentence at the beginning or the meaning of that sentence. It kept connecting those sentences and words simultaneously, so it can understand and have all this context and memory. So it solves these two problems. So this self-attention. It allows the model to look at every word in a sentence and calculate its relationship or relevance to every other word in that sentence or paragraph, regardless of how apart they are. They can be at the beginning and then the other word at the end, and it can calculate their relationship. What are they connected between? So this is the learning connection between all words simultaneously. This is the self-attention is all you need paper that Google shipped. So let's put an example. So we have this sentence. The bank of the river was muddy, so the bank delayed loan approvals. So from this raw text, from these raw two lines, it goes through this self-attention thing, so through this transformer, and now it's able to look at every word and calculate its relationship to it or relevance to every other word. So with this, it knows that the first bank, this bank, it refers to the geographic bank. Then this other bank, it knows that the second bank, it refers to the financial bank you go to take money out or whatever you do there. So this is how self-attention works. It enables this transformer, this neural network, to be able to see the connections between the words, because with the before recurrent neural networks thing, we didn't have that. So thanks to that, now it's able to know the connections, and thanks to the transformers, now we have the current AI models that we have right now. So there are these different types of transformer architectures. We have the first one, encoder only. The encoder only is for understanding, analyzing raw text, raw files, raw paragraph, whatever things about text. So we have this Google thing in here. Then we have the decoder only, that these are ones that generate token by token. These are the large language models. These are Cloud, ChatGPT, OpenAI, Gemini, Grok, DeepSeek, Oyama for local models. This is the decoded only that generates token by token. These are large language models that they transform the prompts that you send from text to tokens. That is their unit they work on. Then we have encoder decoder, a combination of both that converts one sentence into another. This works for translation, speech-to-text tools that we have right now, summarization, this kind of tasks. So we have these three types of transformer architecture. So we have gone through these transformers, what is a transformer, the types, what was a game changer, why am I explaining you the neural networks, then examples of an analysis of neural networks and the layers and everything and how it works. So I hope you understand it better, and if you please did, just give a like and subscribe, because it helps me a ton. It takes time to prepare this, so I would be grateful if you do that, and I will see you in the next video.
That's how I build. One person and every AI in public. The AI that matters every day.